Hello my friends! So are you ready to visualize the linear regression results and the polynomial regression results to indeed understand that the polynomial regression model is way more adapted to nonlinear datasets, meaning to datasets with nonlinear relationships? Alright, so let's do this. Let's create a new code cell, and now you actually know what to do. I should have told you in the previous tutorial to try to do it yourself first, because we're going to code exactly the same as, remember this piece of code we implemented to visualize the results of the simple linear regression model, but it's okay, let's do it together now, quickly. So remember, the first thing that we have to do is call the matplotlib.pyplot module, which has a shortcut plt. Then from this module, we're going to call first the scatter function, which will allow to first, display on a 2D plot the different points of coordinates containing the real results, the real position levels going from 1 to 10 and the real salaries. So that's what we are plotting first, and then we'll plot the predictions. And so, well, here we have to input first the coordinates of these real points containing the real position levels and real salaries. And on the x-axis we have, of course, the position levels. Therefore the x-coordinates will be x, all the position levels contained in x. And then on the y-axis we'll have the salaries, the real ones, and therefore the y-coordinates will be y. Alright? And then remember, we need to add a color, and we'll choose, like last time, red. Perfect. So that's for the real results. And now we're going to plot the predictions. And to do that, well, we're going to call plt again, matplotlib.pyplot, from which we're going to call the plot method, because this time we're actually going to plot that regression line, in blue, like in simple linear regression. And then for polynomial regression, you will see that it's not a line, but it will be actually a curve, and still we will use the plot function for that. So again, we have to enter the coordinates of the different points of this line, and for these coordinates, well, first the x coordinates are still x, the position levels, but then the y coordinates will be, of course, the predicted salaries, instead of the real salaries. And to get them, well, we simply need to call our linreg object, not linreg2. Linreg2 is for the polynomial regression model. Linreg is for the linear regression model. And so linreg, from which we're going to call that predict method, applied, of course, to x, right? Containing the position levels of the matrix of features x. All right, and then we add a color. And like last time, we'll choose the color blue. All right, blue. And then we'll just improve or enhance our graph by adding a title, an X label, and a Y label, and finally display it. So you know how to do this. We call first plt, then the title function. So here we're going to add a funny title, like in quotes, of course, truth or bluff, right? This is the simple scenario I invented for this case study. And then we're going to precise that it's linear regression, the linear regression model. Okay, good. Good title. Now, an X label. So here again, plt.x label. And we'll choose, something simple like position level. Okay, perfect. Then a Y label. So I'm calling the Y label function. And we're going to enter salary, because on the y-axis are all the salaries, the real ones or the predicted ones. And finally, remember that we have to show the graph by using this show function. Perfect. And there we go. We're already ready to visualize the linear regression results. Are you ready? I'm going to close this so that we can see it very well. All right, let's make sure I didn't make any mistake. Yeah, it seems all good. So now let's press play, and here we go. This is the linear regression results. Let's scroll down a bit. All right, so first of all, to recap, the red points here are the real salaries, going from 0 to, I think, 1 million for the CEO. Yes, okay. So these are all the real salaries of this column, okay? And then the blue line is, of course, the regression line containing all our predictions, but the predictions of the linear regression model. So, first of all, we can see that, indeed, the linear regression model is not well adapted to this dataset. Because, indeed, remember that in simple linear regression, it was well adapted because each time, for each of the values of the features, well, the prediction was close to the real result. But here, for many position levels, for many values of the feature, well, the prediction is far from the real result. Here, for example, it is quite far from the real salary. Imagine if we wanted to use that model to predict if someone is saying the truth or bluffing about a salary that is contained here. Well, we would have offered a way higher salary than we would be supposed to. So that would not be the best negotiation. Okay, so that linear regression model is not well adapted. And same here, it is far from the prediction. Same here, far from the prediction. Here it's okay, but that's only for 2 points, 2 salaries. But then here it's super far from the prediction, and here as well. So clearly not well adapted. And that's why I wanted to show you this, because now you're going to see that the polynomial regression results are going to be much better. And now I'm going to show this to you right away. So I'm going to close this, and we're going to visualize the polynomial regression results efficiently by taking this code, because you're going to see that it's going to be almost the same. So I'm going to scroll down. I'll scroll back up to compare, create a new code cell, pasting that here. And now, according to you, what do we have to change here? Actually, something important. Please press pause on the video now and try to figure out, before I give you the solution, what you have to replace here in order to visualize the polynomial regression result. I really want you to think, because it's not that easy. It is easy, but it's not like what you would think at first sight. So please press pause on the video and make that change in order to make it work for polynomial regression results. All right, okay, so now I'm going to tell you the solution. Well, first, of course, we have to change our regressor here, because we want to use our polynomial regression model, which is based on linreg2. So that's the first change, linreg2, yes. And now, in the predict method, do you think we need to keep x or change that by something else? Well, of course, we can't keep x, because remember, x is only that matrix of single feature containing the position levels. Remember that when we use the linreg2 regressor, which is the linear regressor, it has to be applied to the transformed matrix of features x into this matrix of features at the different powers. Position level, then squared position level, and then the other powers. Here we only chose n equals 2 so far, so we only have the squared position levels. But that's exactly what you need to change here. You can't keep x because it is the single feature, so you need to input here that transformed matrix of features x containing the different powers of that single feature position level. And that's, of course, exactly this polyreg fit transform method applied to this matrix of single feature x. So I'm copying this, and that's exactly what we have to input inside this predict method. You understand? So that was the little thing not to forget, and now you're all good. You're ready to have a beautiful visualization of the polynomial regression results. Let's just replace this linear here by polynomial, and now 100% ready. Let's visualize the polynomial regression results. And there you go. Now we have indeed a way more adapted regression curve coming indeed much closer to the real results, the real salaries. Indeed, if we compare to, I'm going to zoom out a bit so that we can see both of them at the same time. There we go. So if we compare these points where we had issues previously with the linear regression model, well, we can clearly see now that the issue is resolved, because indeed the predictions on this blue curve come way closer to the real salaries. And this is only with n equals 2. I'm going to show you then that with higher powers, n equals 3 or 4, well, we will get even better results. And I'm going to actually show this to you right away. So now what we're going to do is, well, we're going to keep this, but we're going to remove this, because we're going to retrain the polynomial regression model with a higher degree. Let's take, for example, you can try with 3, but we're going to directly try with 4. So there you go. I'm going to remove the output, retrain the polynomial regression model on the whole dataset with, therefore, this time a degree of 4, which means that the polynomial regression equation will be salary equals b0 plus b1 times position level plus b2 times position level square plus b3 times position level at the power of 3 plus b4 times position level at the power of 4. So that will be the new polynomial regression equation. And so therefore, let's retrain it. Let's build this new polynomial regression model by just running this cell again. All right, so now we have it. And now very simply, we're going to visualize the new polynomial regression results by clicking this cell here. And as you can see now, the polynomial regression model is perfectly fitting this data set. So here we clearly have overfitting, but that's okay only in this situation because we want to have a perfect prediction of the salary between position level 6 and 7. Okay, and now one final thing, because I really want you to have the best results and best visualizations. Indeed, as you can see here, what happened is that only some straight lines were plotted between each consecutive points of the data set, right? And therefore that makes this curve not as smooth as we would hope for. So I actually prepared another code, but which we won't code together because this is just for the sake of having a more beautiful curve. So we're going to get it from the original implementation. It is actually right here. You see visualizing the polynomial regression result for higher resolution and smoother curve. So I'm going to take all this code and then paste it in our copy of the implementation right here in a new code cell, and you will see that we will get indeed a much smoother and more beautiful curve, as you can see, right? And the trick to plot this curve, I'm going to explain this quickly, is just to, instead of taking, you know, the integers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, we increase the density of these points by taking not only these integers, but, you know, 1, 1.1, 1.2, 1.3, 1.4, up to, you know, 9.1, 9.2, 9.8, 9.9, 10. That's what this 0.1 means. That's what we call the step. All right, so you don't have to understand this. You can if you want, but this is something you will probably do only once in your life, because I remind that usually your datasets will have many features, and here I only took one feature in order to show you the results on a graph, because, you know, if we had many features, I couldn't show this to you because we would have way too many dimensions. So don't worry too much about this, okay? But just appreciate the result, right? We have a very well trained and therefore very well fitted, but overfitted model for this data set. But that's fine, because then indeed we will be able to get an amazing and accurate prediction to figure out if there is truth or bluff. So that's what we'll do in this next and last tutorial. We'll first predict that salary of the position level 6.5 with linear regression and then with polynomial regression. I really encourage you to try to do it on your own first, because it's actually not that difficult. The only new thing that you'll have to figure out will be to, well, figure out how to predict a single observation instead of a whole matrix of features of the test set. But really, if at least you try, well, you will definitely improve your Python skills. So, good luck, and I can't wait to see you in the next tutorial to find out about that prediction. And until then, enjoy machine learning.